Well, isn't this interesting? Not exactly how I expected to start in January. If you remember, before winter break, we were finding area of regions using integration, and I was noticing that we weren't real clear on how to make the graphs, and so I was going to emphasize sketching the graphs when we got back in January. That is not a skill that translates very well to distance learning. I would much rather be in the classroom to be able to give you graph paper. And then if you have questions, it'd be real easy for you to raise your hand and I can either address the whole class or I could hustle over to your table and point things out. Graphing is just not the easiest thing to do. So we're going to evaluate expressions, just kind of refresh our brains because we've had a couple weeks off. And hopefully we'll be back in the classroom next week and then we'll just resume what we were doing. If we were not back in the classroom next week, gads, I guess we'll just have to try to do some graphing over the internet. Okay, but we're going to try to just evaluate expressions today. Our memory devices for order of operations. We've got our purple elephants merrily dance after sunset. We've got our purple ears make dairy animals super. We've got our parachuting emus may drop around Seattle. The old-fashioned please excuse my dear Aunt Sally. And of course, a lot of us just remember PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract. Wait, huh? Dragons? Purple dragons? Oh my goodness, purple, energetic, magic dragons appear suddenly. That's another memory device. How about that? Now, when we're evaluating, we go in the regular order, right? When we're solving for like a mystery number X, that's when we go backward and undo things. But evaluating, we just go in the normal order. We will start by doing anything inside parentheses. If there are no parentheses or if we complete them, we'll then look for exponents. After completing any exponents, this is where it gets tricky. Remember, it's multiply or divide from left to right. And then the last step will be add or subtract from left to right. Okay, let's get some examples up here. Start with the super basic one, just to kind of reorientate ourselves. We're like, hey, I don't see parentheses. I don't see an exponent. So I better do any multiplying or dividing. So 5 times 2 makes 10, right? I had to do that first. Now it's add or subtract from left to right. So I'll have to do the subtraction before the addition because I got to go from left to right. So 7 subtract 3 gets 4. Then 4 plus 10 is 14. And that is the answer to the first question. Hey, here comes another example. Oh, a little bit more going on here. Remember, we have to do inside the parentheses first. Yes, there is a set of parentheses here. Remember that square root symbol is one of our grouping symbols. It acts like a set of parentheses. So I must do inside the parentheses first. In other words, inside that square root symbol first. So 17 plus 8 is 25. Okay, there's nothing else inside parentheses I can do, so now I look for exponents, and I see 2 different exponents. I see 3 squared, but I also see 25 to the 1/2 power. Remember that square root symbol, besides acting as a set of parentheses, also says, hey, there's an exponent of 1/2. So I'm going to do the exponents now. 3 times 3, of course, is 9. And the square root of 25 is just 5. Now I look for any multiplying or dividing. So I'll do 4 times 5 is 20. And then I can do any adding or subtracting. And of course, 9 plus 20 is 29. Now you're thinking, oh, come on, we're in calculus. This is just way too basic, way too easy. We always got to practice our trigonometry skills, don't we? Even though we're evaluating, look what we've got here. We've got tangent of pi over 4 minus cosine squared of pi over 6. Now, first thing I really need to realize is that there is a set of parentheses here, right? You don't see them right away, but you have to realize when we see cosine squared of pi over 6, that's really cosine of pi over 6, that entire quantity squared, right? So I actually do have a set of parentheses. Now, there's not much going on inside of them. In fact, I don't even understand what numbers I'm working with. So let's figure out tangent of pi over 4, and let's figure out cosine of pi over 6, so we can get some numbers in here. Tangent of pi over 4, of course, that's a 45-degree angle. Opposite over adjacent is going to have a ratio of 1, because opposite and adjacent sides of a triangle, of a 45, 45, 90 triangle, will be identical. So tangent of pi over 4 is just 1. And of course, cosine of pi over 6, we are in that little tiny 30-degree angle. Adjacent divided by hypotenuse is going to get us a root 3 divided by 2, because adjacent to that little 30-degree angle is the longer leg. All right, so now I can see I've got 1 subtract, and then inside parentheses a root 3 over 2 with that whole thing squared. So I can move on to the exponents. Root 3 times root 3, of course, is 3. 2 times 2, of course, is 4. So we've got 1 minus 3/4. 1 can change into 4/4. So we subtract, and we end up with 1/4. I'm going to have submissions enabled on Schoology, so if you prefer to email me a document or email me a photograph of what you did, you can do it that way. If you prefer to submit your assignment via Schoology, you can do it that way. You know, whatever makes life easier for you is what I'm aiming for. Also, you'll notice that the assignments are available either in Word or PDF document for download. If you use the Word document, I do not recommend you open it in Schoology because weird things happen with that. Right? Either download the Word document and then open it, or if you want to just open something, I'd use the PDF. And if we're back in class next week, we'll resume where we left off. If we're not back in the classroom next week, we're going to get creative on how to do some graphing remotely. Hoping that we're all back next week, because this is ridiculous. I'm not talking about the cows.